Hope everyone's had a good chat. Now, what I'm going to do is maybe a little controversial, but maybe you'll eventually be convinced. So what I'm going to do is talk about maybe some things we could do to improve education a little bit. And you may all know that feeling when you go into a lecture and you're excited to learn about physics, hopefully, and you want to really understand what's going on, and then the professors hit you with an hour of lecture slides with full of equations, and then they hit you with these slides that you can't understand, and you get really bored, and then by the end, maybe you get a nice few pictures here and there that you're like, oh, okay, that's kind of cool. But then, well, this is what happens. You go and have that lecture an hour before, you're kind of concentrating, and then an hour later you go, what the fuck did I just listen to? So that's where we need to think about, well, what would we do instead? Well, we know that students like me will go and maybe read on Khan Academy, we might go watch 3 Blue 1 Brown, we might go see Veritasium, some good mentions, minute physics, maybe space-time, and we really like them because they give us something different. They kind of engage in the content, and they're really nice for us to watch. And you can see they've got billions of views that keeps them going. And so the question is, well, what keeps everyone going towards people like them and not to the lectures? We've seen that kind of over the last few semesters. Lecture attendance has really gone down. So what's going on here? Well, I think what's going to be the important part is putting together education with maybe a few visualization techniques. So what I'm going to go through is maybe a little different. So I'm actually from a maths background, and I did physics in undergrad, and I'm now just doing some geometry work, and I've actually kind of been really interested in visualizing things, especially because I'm kind of doing a bit of HSC, like tutoring and teaching, and this is some stuff I've been really interested in, how you can really visualize things and make it engaging for students to actually want to learn stuff. And I've also luckily been working as a robotics engineer on the side, and so I kind of got to put together these education things with a bit of understanding what's going on in kind of a 3D physics sense. And so when I put these together, then I thought, well, we need to think about what is a good lecture, right? Well, obviously, because we're talking about science, it needs to be scientifically accurate. Well, I would argue that this is about just the only thing the average STEM lecture gets right. Now, what else do we need? Well, I said before, we should be engaging, and that's where all these content creators were. And so they're kind of in the intersection here with scientifically accurate and engaging. But then the question is, well, what's wrong with that? Where's this extra circle coming from? This is where we have to think, well, professors don't have that much time, they're trying to get grants, and they don't want to spend their time doing that. And so what we instead need is something else. We need to make it quick to make, we need to make it quick to interact with, it should be fun. And so what we do is think about a different way of doing things. And so here I've kind of shown you what I was making. It's like, you got these visualizations, but then the question is, how do we make this actually usable? Because this thing I wrote up in Python and no one knows what that is, no one wants to use it. You might make it in MATLAB.
Who knows what Python is?
No. Okay, some of you know what Python is. You might have something else like C++. Who
thinks Python is a snake?
And of course, if you're really nerdy, you might go for JavaScript. But of course, we can't do that because they're all a pain to run and students don't want to have to do that, and neither do the lecturers. So what are we trying to do? Well, this is where I present something, a bit of a weird suggestion, but you'll see in a second. What is in the intersection of all these three? Well, I say it's actually Desmos. Now what the hell is that? Woo, Desmos, yeah. Well, what is this? No one's heard of it, probably. Well, this, you may think, well, it's probably some joke tool that you might have seen once. In fact, in high school, you might have seen it as some like y equals mx plus b tool. You show your like equations moving around in class, and then the kids go, oh yeah, okay, sure. But then I'm going to tell you, actually, this Desmos thing is actually a Turing-complete beast. If you don't know what that is, that just means you can literally do anything with it. You can really like code up anything you want, and that is where I show you some new stuff, like when I was creating this Python thing. I mean, it looks nice, but you really can't really run it if you're not someone like me that maybe knows what Python is, for example, and I tried to show it to someone, they had to go and open a terminal? Like, what is that thing? What the heck is that? So we need to come up with a different way of doing things, and that's when I went and implemented this whole thing in Desmos. In fact, how do I do this? Well, you'll see there's a lot of tricks that Desmos has, and in fact you can create many visualizations that are all possible because Desmos is Turing complete, and that means you can do anything. So you've got other examples, like you might show how an AC induction motor works, like when you have your physics demonstrations of things. You might even do demonstrating how a neural network works around. So these are your machine learning things. You might have other things like virtual photons from quantum electrodynamics. If no one knows what that is, that's something. You've also got things like, Einstein's relativity. You've got the time dilation. Maybe you want to visualize that. And then you've also got things like the double slit experiment. I mean, what the heck? How is this possible in Desmos? Well, I'll explain in a second. You can also do things like orbital mechanics. How planets are moving around, orbiting. You've also got things like parallel transport. What is this? This is sort of how, in Einstein's relativity, you've got movement of trajectories of planets, going towards sort of the optimal route to go around and have their minimum sort of displacement. That's kind of the idea. I mean, it's a bit vague. And you may do other things like optics. You might show off how reflection and transmission works. And this is really where the power of Desmos and these two tools here, these are GeoGebra actually, so they're kind of, if you want to extend, doing more than just your basic stuff. And this is where I really think it's the power coming in. So how do we do this? Well, there's things called tickers. These are Desmos things that allow you to basically go and essentially simulate a for loop, like doing a kind of a repeated process. And then you can eventually do other cool things, like you have n-dimensional vectors, which allow you to basically describe multiple numbers. You've got heaps of things like parametric equations, multivariable functions. You've got least squares. You've got RGB color interpreters. You've also got implicit function solvers, whatever that is. You've also got parametric integrals. You've got discrete sums, like what? And you've also got distributions, from statistics, and there's many more. So I think if maybe once or twice in a lecture, make a little quick 1 hour or 2 demonstration of these things using something that could really help improve the way people learn. And I think that's sort of the game I'm going with, and hope you enjoy. And that's my talk.